and this is the URL, base URL for where the COMET protocol is running. So this would be routed to the rack middleware, and you can have other rack middlewares running serving different addresses or however you want to implement it. I then subscribe to, here's example chat demo, and you've got your callback function. When you receive a message, this function is going to get called with a message that's come as a result of that subscribe. Does that, anyone not enough JavaScript to know what that means? Is that easy enough? At some point later on, someone pushes a button, types in something, and hits enter. You're going to want to publish to that channel. Here's a JavaScript object which will be serialized. This is just the connect message from the chat protocol saying, hey, tell anyone listening to the chat that I'm Joe and I'm connecting. And that message will go out to anyone who's done this subscribe. And so that object will appear here in someone else's browser. Okay, that's what we're trying to achieve here. The jQuery COMET API has start batch and end batch, so you can say, I've got a bunch of things to tell you, I don't want you to send them until I say end. Now, as it turns out, if you have a loop iterating through publishing, and then I'm done, it won't start sending on the first one anyway, because I don't send until a timeout 0 has occurred. So it'll automatically batch things up for you within one event context, within one click or within one action. But if you have a reason to want to batch things up in a more robust way than that, then there's the start batch and end batch APIs. And in addition to subscribe and connect, you can unsubscribe and disconnect. It's kind of obvious. I'll give you the GitHub URLs for that. Okay, on the Sinatra side, this is actually not the code, but it's close. Just a sec. For the back end. Yes, Daniel?
So you just say that it doesn't batch things up until you return, or until you time at 0. Is that on all browsers? Because I was under the impression that Chrome runs the JavaScript and so it runs Ajax, JavaScript, and the actual render in separate threads.
Yeah, but jQuery.com doesn't actually make the XHR request. When you publish, the message goes into a client-side queue. Right. And it sets a timeout 0 to say, after we stop having things to do, send the stuff that's been queued inside the browser. So you can queue as many things as you like, as long as the browser doesn't run out of work to do. As soon as it runs out of work to do, one of the timeouts is going to go off, and then it makes the XHR request. So that's how it works. Oh, I mentioned the cross-domain thing. If you do specify a location to connect to, which is not the location the page was served from, you can't do XHR requests across domain. There are hacky ways around that work on some browsers, but in general, there's cross-domain rules. And so what the jQuery commenting will do is it'll switch over to JSON-P. Anyone not know what JSON-P is? Anyone know what JSON-P is? JSON-P is basically any browser that receives a page from one server can load the script for a script tag. It will load in the valid script that's served in the script tag from that server, even if that script comes from a different server. So what JSON-P does is it writes a script tag into part of the page that says, please go and load this URL. Now, because it's doing a get on the script, it'll be a get question mark with parameters appended. And so the message you can send is limited in size. So if you publish too much stuff and then expect it to send that message across domain, it's going to blow up probably on the server side, because it'll get an incomplete HTTP request because there's too much data on the URL. There's a limited size, a K or so on the URL that you can send. So anyway, JSON-P is there as kind of a mechanism for cross-domain stuff if you want to use it, but be aware of the limitations. Okay, so Bayeux is a Sinatra object. It derives from Sinatra base, and here I'm declaring a chat server, which is a Bayeux subclass. I'm configuring my public because I want to serve files from, I want to serve the HTML somewhere. If I get slash, I want to do an ERB on the index file. And finally, Bayeux has a deliver method which handles the internal Bayeux protocol. and I've got a bug in this code because if this channel is the chat demo channel that we're interested in, I need to do this work, otherwise I've got to call super, and I haven't called super here. I tried to crunch it onto one slide and not make the font too small. But bottom line is, we've received a message on the channel. When we determine it's a channel we're interested in processing, a chat message, I can then just go publish this data to that channel and return this to my caller. So this tells the person that sent the initial message that their send was successful, and in addition they'll see, and everyone else will see, the message being published. And what this does is all the clients are waiting on an event machine subscribe, so they've got a call but in event machine waiting for something to be published, and when a message gets published is on a channel that they're subscribed to, we post to those event machine channels, and they wake up and they'll return a response using async Sinatra. So with the exception of my super call, you could actually use this to run a complete chat example. Well, semi-complete. It doesn't have login, but the code's all there if you want to play with it anyway. And it's a gem, so you've just got to require the gem, install the gem, require the gem, and write your server. And that's a rack middleware, which you can then use in conjunction with another app, a Rails app or another Sinatra app or whatever. So you can run, I don't know if you know how rack literally racks up applications, so you can run multiple of them at the same time. It's Sinatra modular. So the two things are up on GitHub. I think I did actually go and publish a gem for this, so you should just be able to go gem install Bayeux rack. And the jQuery stuff's up on my GitHub as well. There's a chat demo there, which I'll show you in a minute. So there's a few things to do with the status. It uses client IDs 1, 2, 3, which is open to attack, and you should create your own client IDs, but that's just one of the methods saying new client ID, so you just provide your own one. There's no detection of dead clients, like if a client polls, we'll publish messages to it, and if it never polls again, we'll just keep on queuing up messages and never send them, so that's got to happen. I don't yet try and detect the multiple tabs. If you have to stop the server, the client might go and poll, the server will say, who are you? The client has to figure out how to reconnect, and it doesn't automatically do that yet. And I haven't done the server timeout. It's kind of hard to automate this stuff. If anyone wants to talk to me about how to automatically test all this asynchronous stuff in a browser, I'd like to hear about it, because I scratched my head about it for quite a while, and I've tested it manually, and I've injected JavaScript into it to do various things with it, but as I say, I've rewritten the JavaScript code several times, but to a point where I think it's correct. It's been through some stress tests by a few other people as well, but it seems to work. But you know, your mileage may vary. I'm not guaranteeing it because I haven't actually got a formal test suite for it, and I'd like to know how to do that. Someone wants to tell me how to do it. So, any questions before I show you a demo? Mike?
Is it easy for the server to consume and publish messages as well, or is it mainly built as a conduit between clients?
I haven't written a Ruby-based client for the COMET protocol. Is that what you're asking?
I'm just wondering if stuff that's running within the Sinatra app can also take part in that communication.
Yeah, anything can publish at any time.
Right.
On any channel.
So a get or a post to another endpoint could publish.
Yeah, of course. You can publish to any channel at any time from Mortis any code. I mean, you've got to do it on this object, so that object's got to be available. But so if I've got another server and I know the idea, but I can say, you know, diagram server.publish blah to some channel, and it goes out to all the clients that are listening on that channel at that time, or that are thought to be likely to reconnect on that channel if they haven't been seen, if they haven't been declared dead yet, right? So it's pretty straightforward to use. And the other thing is the code's actually pretty simple, because async Sinatra makes this stuff pretty easy. It gives you don't have Sinatra, you have a get method and a post method. You get a get and a post. What it does is async Sinatra hacks thin. You've got to use this with thin. It actually hacks the thin implementation. it's quite satisfyingly simple to read the code, but it does your head in for a little bit until you get your head around evented and asynchronous stuff. So I don't know if it's actually that interesting, but hello. So there's the there's a magic comment inside of config.au which gives it the port number. So that's where it's got port 8080 from. And here I've got so foo's joined. Let me now start up. I've got Firebug running. Sorry about that. Go away, Firebug. Hello, what's happening here? So there we go. And I've got to now join. And so you can see that the Chrome there has said bars joined. Hello. It appears in both. So that's really all there is to it. But I mean that's just an example of messages. That could be any data being passed around to any kind of user interface. Pretty simple demo, but that's really all I'm doing with this. So fun stuff. Have a play.
Cool.